Hi dear students, this particular class I am going to discuss about the main part of the probability that we will call it as conditional probability. So conditional probability, probability of A under the condition B, probability of A with respect to B, probability of A when B is taken as a sample space, probability of occurrence of A under the condition that B has already occurred, that is P of A by B. Now how to find out P of A by B? Just observe here. We have to find out the probability of A under the condition that B has already occurred. So this is a set A and this is a set B, right? So we have to find out the probability of A with respect to B. Probability of A when B is taken as a sample space under the condition B. Under the condition B. When B is taken as a sample space. When B is taken as a sample space, we have to find out the probability of A. That means this one. When B is taken as a sample space. When B is taken as a sample space, probability of A is equals to this particular portion is the favorable one, right? So that's why we can write this one as number of elements in A intersection B divided by number of elements in B, right? That same we can write number of elements in A intersection B divided by number of elements in the sample space S by number of elements in B divided by number of elements in the sample space S. Numerator divided with n of S, denominator also divided with n of S. Now what happens? Number of elements in A intersection B divided by number of elements in S is nothing but probability of A intersection B. Next, number of elements in B divided by number of elements in S is equal to probability of B. So that is probability of A by B is equals to P of A intersection B divided by P of B. So we can write in the similar way P of B by A. That means probability of B under the condition that A has already occurred is equals to P of A intersection B divided by P of A. Here P of B not equals to 0. Here also P of A not equals to 0. That is about the conditional probability. Now here we are going to discuss a few ideas in this conditional probability along with the multiplication theorem on probability. What is a multiplication theorem on probability? A comma B are any two events associated with the sample space S of a random experiment. Then P of A intersection B is equals to P of A intersection B is equals to P of A. Probability of occurrence of A and B. Probability of simultaneous occurrence of A and B. P of A intersection B is equal to probability of occurrence of A into probability of occurrence of B under the condition that A has already occurred. P of A intersection B is equal to P of A into P of B by A, or we can also write that one as P of A intersection B is equals to probability of occurrence of B into probability of occurrence of A under the condition that B has already occurred. So this is the multiplication theorem on probability. This is the multiplication theorem on probability. Actually nothing to discuss here. Earlier we already discussed, we know that P of A by B is equals to P of A intersection B divided by P of B, whereas P of B by A is equals to P of B by A is equals to P of A intersection B divided by P of A. Now here cross multiplication, you will get P of A intersection B is equal to P of B into P of A by B. Here also cross multiplication, you will get P of A intersection B is equal to this one. Sometimes in the board exam they may ask for a proof of the multiplication theorem on probability. That's why few steps how to prove that I am to discuss. All of you pay attention here. A comma B are two events associated with the sample space S of a random experiment. This is A and this is B. Total there are M1 elementary events favorable to A. M1 elementary events are favorable to A and M2 elementary events are favorable to B. M1 elementary events are favorable to A and M2 elementary events are favorable to B and M be the number of elementary events favorable to both A and B. And here N denotes total number of elementary events associated with the sample space S of a random experiment. Now can you tell me what is P of A? P of A is equal to favorable M1 divided by total number N. At the same time P of B is equals to favorable M2 by total number. At the same time P of A intersection B is equals to M divided by N. Now from here can you say what is P of A by B? Probability of A. Probability of A with respect to B. Probability of A when B is taken as a sample space. When B is taken as a sample space. B we are taking sample space means how many elementary events are there in the B? M2. Right? Probability of A under the condition that B. Probability of A when B is taken as a sample space. That's why M2. For in these cases, how many are favorable to A? M are favorable to A. But this one, under this case, the probability of A is asking, that is M divided by M2. In the similar way, can you tell me what is P of B by A? Probability of B with respect to A. With respect to A means under the condition M1 is the elementary events, right? So that is equals to M1 favorable is M. So that is P of B by A and here we got P of A by B. But we have to find out P of A intersection B. Now P of A intersection B is equals to M divided by N. That we can write it as M divided by M2 into M2 by N, right? Or we can write M divided by M1 into M1 by N. What we are doing? Multiplying with M2, dividing with M2. Multiplying and dividing with M2. Now what happens? M by M2. M by M2 is nothing but P of A by B into M2 by N is nothing but P of B. Whereas here M by M1 is nothing but P of B by A. P of B by A into M1 by N is nothing but P of A. So that's what the multiplication theorem on probability. So P of A intersection B is equal to P of A into P of B by A. That's what we got here. P of A intersection B is equal to P of B into P of A by B. That's we got here, right? So in both the cases here, P of A not equals to 0. That's what we discuss in here. Because P of A by B is equals to, in earlier conditional probability we discussed, P of A by B is equals to P of A intersection B divided by P of B. Now here P of B not equals to 0. Similarly in this case P of A not equals to 0, right? So that is the multiplication theorem on probability. This proof may be required for the board exam purpose. Okay, so that is the discussion we did. P of A intersection B is equals to probability of A into probability of B under the condition that A has already occurred. Similarly, we can discuss multiplication theorem for two or more events also. This is multiplication theorem for two events. That's we can write it as P of A intersection B intersection C is equals to P of A into P of B under the condition that A has already occurred into P of C under the condition that A and B are already occurred. So that is multiplication theorem for three events. Now in this conditional probability, so I want to discuss a few properties, because as you know, probability of occurrence of A is always lies in between 0 and 1. That means probability of occurrence of A belongs to closed interval 0, 1. But what about the conditional probability, right? So these type of points I want to discuss. The first one is P of S by A. P of S by A is equals to P of A by A, that must be equals to 1. So observe here, P of S by A is equals to, according to the conditional probability definition, we can write S intersection A divided by P of A. Now S is the sample space, like that universal set, and A is a subset of S. A is a subset of S. Now S intersection A, what we will get? A only. So that's why you are getting P of A divided by P of A, so that value is equals to 1. At the same time, we can show P of A by A is equals to P of A intersection A divided by P of A. Now here also what happens? A intersection A is equals to A. That's why you will get P of A divided by P of A, that is equals to 1. Right? So the other one we are discussing, as I told to you, probability of A under the condition B is also lies between 0 and 1. How? That I want to discuss. Probability of A under the condition B is also lies between 0 and 1. As we know that A intersection B is always a subset of B. A intersection B is always a subset of B. That's why I can write probability of A intersection B is less than or equals to probability of B. At the same time, this is always greater than or equals to 0. Right? Probability you will always get greater than or equals to 0. Because as I told, P of B also positive. When it is a positive, you can divide throughout the inequality without affecting. At the same time, P of B not equals to 0. When P of B not equals to 0, in this case P of B not equal to 0, we can divide. So that's why dividing with P of B 0 less than or equals to P of A intersection B divided by P of B less than or equals to 1. So we are getting 0 less than or equals to conditional probability P of A by B less than or equals to 1. Conditional probability is also lies between 0 and 1. The next one is, what about P of A bar by B? P of A bar by B is equals to 1 minus P of A by B. P of A bar by B is equals to 1 minus P of A by B. How? Just observe here. As we discussed earlier, P of S by A, P of S by A is equals to 1. Okay. So before going to discuss this particular result, just we will try to prove one more result. What is that? I hope so everyone familiar with the conditional probability, addition theorem on probability. P of A union B by C is equals to P of A union B by C is equals to, what is P of A union B? P of A plus P of B minus P of A intersection B, that is addition theorem on probability. P of A union B by C is equals to P of A under the condition C plus P of B under the condition C minus P of A intersection B under the condition C. Now this particular result also I am going to prove. Pay attention here. As you know, P of A union B by C can be written as P of A union B, right, intersection C divided by P of C, that is according to the conditional probability. P of X by C is equal to X intersection C divided by P of C. Now according to the distributive law, we can write this one as P of A intersection C union B intersection C. Just I applied the distributive law by P of C, right? Now this is X and this is Y. X union Y. According to the addition theorem on probability, P of X union Y is equal to P of X plus P of Y minus P of X intersection Y. So what we can write that one as P of A intersection C plus P of B intersection C minus P of A intersection C intersection B intersection C whole divided by P of C. Now C intersection C, all are intersection only. We can write this one as P of A intersection B intersection C. Now this is equals to P of A intersection C divided by P of C. Next one is P of B intersection C divided by P of C. The next one is minus P of A intersection B intersection C divided by P of C. What we can write this one? This we can write it as P of A by C. Next one P of B by C. The next one we can write P of A intersection B by C. So that is about the addition theorem extension in case of conditional probability. But now here, if A comma B are mutually exclusive events, if A comma B are mutually exclusive events, what happens? P of A intersection B becomes 0. So in case of mutually exclusive events, we can write P of A union B by C. We can write it as P of A by C plus P of B by C. If A comma B are mutually exclusive events, then we can write P of A union B by C is equal to P of A by C plus P of B by C in case of mutually exclusive events. So now we can prove the earlier one. What is that? P of A bar by B is equals to 1 minus P of A by B. Just observe here. We know that P of S by A is equals to 1. P of S we can write it as A union A bar divided by A. Right? Now A and A bar. A and A bar are mutually exclusive events. When they are mutually exclusive events, what we can write this one? This we can write it as P of A by A plus P of, just a minute here, instead of writing this one, better to write P of S by B is equals to 1 because we have to prove this one. So P of S by B is equals to 1. Yes, I am writing A union A bar by B. Now I can write this one as P of A by B plus P of A bar by B is equals to 1 because P of S by B is equals to 1. Now from this we can write P of A bar by B is equals to, shift to that side, 1 minus P of A by B. So these are the few ideas on conditional probability, right? Next class we are going to discuss about dependent and independent events, that we will discuss in the next class. Okay, bye bye.